This demonstration is going to walk you through some of the things that you're going to be doing with piecewise functions. And even though this is going to have tasks that are carried through an entire way, you might be asked to do various pieces of this in certain problems. So keep that in mind. So this first one here, you're given this table that has the year and the price of a first club stamp. And basically, it just, when 2007 hit, it rose to this. When 2008 hit, it rose to that. So there's nothing going on in between 2006 and 2007 that, it's not going to 39 and a half cents to 40 cents. It just jumped to 41 cents. So a piecewise function is what's going to be used for this. And this was going to be more along the line of a step function, because a step function is going to be a piecewise function where you basically have nothing but constants involved in the function. So that's the first thing you're asked to do here, is construct a step function describing stamp prices for 2006 through 2010. So letting x be the number of years after 2006, so this would be 0, 1, 2, and 3. You can see it's 39 cents when you're at 2006 and all the way up until 2007, right before it. Not including 2007, but everything up before that, it's going to have a price of 39 cents. Then when you hit 2007, it's up to 41 cents. So when you get to 2007, which is 1 year after 2006, and all the way up to the x value of 2, where you're at 2008, it's going to be 41 cents. And then 42 cents from 2008 all the way up to 2009. And then anything beyond 2009, we don't really know what goes on after that. It's 44 cents. You're taking this up to 2010, but you don't know what goes on after 2010 because the table doesn't go that far. So you have to work under the premise that it's probably going to keep doing that for the time being. So when you graph this, and one of the reasons why you'll see this often done, especially with years like this, you'll often see that they'll pick the first value to be the initial value and just make that 0, and everything else accordingly is adjusted from it. Makes graphing a little less tedious. It also makes the equations you get have values that are a little tamer, let's say, than if you don't. Sometimes you'll even see a graph with this kind of symbol here. This little symbol here indicates that, okay, even though we're zeroing out down here, we actually have a skipped portion of the graph here because this first marked value up here is 30. And you can see as we go every 5 spots is 10 units. Obviously, you're not going the same distance to go from 0 to 30. So you're missing a portion of the graph, and that's what this little symbol down here means. But if you were just graphing this, it's going to be at 39. As I said, these are going by 2, so 39 would be here. So from 0 to up until 1, it's going to be here. Open circle here. And then at 41 cents, you're going to be at that for 2007 to 2008. So 41 cents would be here. So you're actually at 41 here until you hit this spot right here, up until right before this. Then after that, you're at 42 cents all the way up to here. And then after that, you're at 44 cents, which would be right here, closed dot. And this one's going to end with an arrow because even though you only have up to 2009, you're told to take this up to 2010 at least. It can keep going from there because you don't have any information that says otherwise. When graphing a piecewise function, you have to use skills that you would also use to evaluate certain values of the piecewise function. So here, if you want to do an accurate graph of this, first I'm going to set up a table. Now, I could use certain aspects of slope-intercept, but really only one, this one right here, when x can be 0, is the y-intercept going to actually show up. So these others are in slope-intercept form, but the y-intercept doesn't enter into it. You could use that, but you have to also keep in mind that you won't be able to start the graph at the y-intercept. Here you start at the x value of 8, here you'd start at the x value of -4. So the way that it's usually done is that there's 3 different pieces of this function here. So splitting this table into 3 different pieces, just going to work on each piece at a time. And because these are linear functions, you only need 2 points that each one of these lines pass through to get the shape of the line. So here, since -4 is included, Negative 4 is going to be a value that's going to be used, and one that's smaller, negative 5. And all it's going to be done is these are going to be substituted into this first equation. So negative 5 is put into that formula, negative 4 is put in that formula, and you would calculate these two values here. So negative 5, 0, negative 4, 2. And the line would look like this. Now for this middle portion. Now obviously, as I mentioned before, the 0 falls in here. That would give you the y-intercept of 4. That's an easy one to calculate. However, you also want to make sure you have the endpoints involved. You say, well, negative 4 and 8 are not included here, but every value up until those are included. So you still want to include the endpoints. But one of the things that I usually do for my own clarification is that I'll circle these to indicate, well, these are going to be open dots on the graph because these are being approached but not reached. And so then at that point, each one of these gets put into this middle formula and calculated, and these are the values you get. And so these would be plotted. So negative 4, 10, 0, 4, 8, negative 8. These two with open circles. And then that's the line segment between them. For the last portion, again, you want to definitely start at 8. And then you want to go at least beyond 8. Now, 8 is going to work well with this 3/4 because if you do 3/4 of a multiple of 4, you're going to get an integer, and this is scaled by integers. So sometimes being selective about what x values you use is a good idea. So 8's already predetermined. I'm going to use 12 as well because it's also a multiple of 4. And when those are substituted into this formula here and calculated, these are the values that you get. And so at 8, 1, close dot, at 12, 4, and then complete the line because it keeps going on forever. And this is what the piecewise function would look like when it's graphed. Of course, the reversal of that is that you may be asked to write the piecewise function having looked at the formula. Now, sometimes these piecewise functions may connect, so there might be some variation about where the less than or equal to goes versus the less than symbol or what have you. Just make sure that as you report these, that you are keeping in mind about the vertical line test. You should not have two different formulas that are used to figure out any one x value. So here, you do know there's 3 different pieces, so you're going to have 3 different sections. You have one when x is less than or equal to negative 3, one between negative 3 and 4, not including the negative 3, but including the 4, and one when x is greater than 4. So when you set these up, those are going to be the 3 conditions you have. You need to come up with the formulas. Also keep in mind that if you look up more information on this elsewhere, you may see these represented with the word if instead of for, but it doesn't really matter. So looking at the first segment, and following along with this, starting here at negative 3, 0, if you follow along, you get another well-defined point here, which helps you figure out that this slope, now as you measure slope, it's always going from left to right. It is up 3, right 1, so it is a slope of 3. And knowing it passes through this negative 3, 0, you can write this in point slope form as y equals 3 times x plus 3 plus 0. Of course, the plus 0 you really don't need. So that's it in the point slope form. Between negative 3 and 4, it's a constant. So you're just going to have the constant value of the y being 2 here. So just 2 is going to go here. And for this last segment, again, starting at 4, negative 1, even though it's an open dot, but it is passing through that point, though the linear pattern is, you want to see where the next well-defined point is. So following along, it's happening right about here. And so the slope, you're going up 3, right 4, so your slope is 3/4, which means that if I'm using this point as a point of reference for the equation, you're going to have f of x or y equaling 3/4 times the quantity x minus 4 minus 1. And this is one way of writing it. Of course, you could take these two pieces, distribute, and combine any like terms to get it more of a slope-intercept look. And so you could actually have these as well as your formulas for the piecewise function. It doesn't matter as long as you have a formula that actually gives you the linear portion. That's all you need. But that is the end of this demonstration video. If you have any additional questions, make sure to bring them up in class.